Assalamu alaikum. Students, today we are going to discuss about the geometric progression. अच्छा, geometric progression क्या है थोड़ा सा इसको जान लेते हैं. लास्ट क्लास में हमने डिस्कस किया था geometric progression के बारे में. अच्छा, geometric progression क्या कहती है? If you have a sequence, like we have a number starting with 6, and we multiply this number by a specific number. Suppose I multiply by 2. So I'll get the next number 12. Now if I multiply this 12 by 2, so I'll get 24. If I multiply again by 2, this is 48. Again multiply by 2, that will be 96. This is called geometric progression. That you multiply by a specific number and you got another number, a sequence, is called geometric progression. Similarly, what we observe, suppose we have a sequence here that is starting from 81. What I do, the next number of the sequence is 27. Oh. How this will happen? What I did here, I multiplied by this by 1 upon 3. I got 27. Again I multiply by 1 upon 3. I'll get the number 9. If I multiply by another number, 1 upon 3 is going to be 3. If I multiply by 1 upon 3, I'll get 1. So what you observe here, that I multiply by the same number and I got the next number continuously. But what we found, difference between the two geometric progression. This is geometric progression, this is geometric progression. So what is the difference between the two geometric progressions? First one is, this geometric progression is an increasing progression. This geometric progression is a decreasing progression. Secondly, what we observe here, we multiplying by this number, it's a number which is greater than 1. And here, the number by which we are multiplying is less than 1. This specific number, the number by which we are multiplying each term, is called common ratio. Common ratio. What we call it? Common ratio. So what we concluded here, and for this we use a symbol r, small r. For the common ratio we use a symbol r. In this sequence, what we observe here, that it is an increasing geometric progression, and here the common ratio r is greater than 1. In common ratio r will be greater than 1 if it is a increasing progression. And if it is decreasing progression, common ratio r will be less than 1. These progressions, the geometric progressions which are increasing, which have common ratio greater than 1, are also called as divergent. Are also known as divergent. Similarly, the progressions in which the common ratio is less than 1 are called convergent. So these kind of two captions you must remember. Divergence means a geometric progression with common ratio r greater than 1 or increasing geometric progression. When you have a decreasing geometric progression in which common ratio r is less than 1, the series also known as the convergent. If you notice here, as you multiplying in this progression, as you multiply, the numbers are increasing immensely. Exponential growth, you can see 6 and the fifth term is 96. The next term and the next term and the next term, they are increasing exponentially. That is why we call it divergent. एक्सपेंड हो रहा है, फैल रहा है, डाइवर्ज हो रहा है. सिमिलरली अगर आप गौर करें यहाँ पर कन्वर्जेंट सीरीज में, your first term was 81 and your fifth term is 1, there is a big exponential difference. आप देख सकते हैं exponentially ये reduce हो रहा है. Therefore you, as you go further, time numbers of are decreasing very immensely. That is why we call it convergent series. अच्छा जी, आप कुछ और डिस्कशन इस हवाले से आइए देखते हैं. लेट्स जनरलाइज द सीक्वेंस. लेट्स जनरलाइज द geometric progression. Yes. Suppose we have a first term, we start geometric progression with a, and we multiply by a number, which is a common ratio r. So the second term will be ar. Again we multiply by r and we will get ar square. So we multiply again to get the next term. It's going to be ar cube. So it's going to be ar square, ar cube, ar4, ar5, so on so forth. Let's observe further. Can we express in this way that ar to the power 0, ar to the power 1 minus, ar to the power 1, ar square, ar cube, ar4 and ar5, or it can be expressed as 1 minus 1, 2 minus 1, 3 minus 1, 4 minus 1, 5 minus 1. Now you can see this is our first term, this is our second term, third, fourth and fifth. So you can see this a is common in each term, r is common in each term. What is going to be changing? The first number before minus. 1, 2, 3, 4, 5. And you can see when you have a first term, it is 1. When you have second term, it is 2. When you have third term, it's 3. When you have fourth term, it's 4. When you have fifth term, it will be 5. If one asks you to find the term 19th term, 19th term, so it's going to be a r 19 minus 1. Let's generalize the expression. If we are looking for the nth term, it's going to be a r n minus 1. This is the way we can generalize the formula of geometric progression. Okay, let's discuss the formula. What are the ingredients of the formula? तफसील से इसके सारे एलिमेंट्स को अपने पास नोट करेंगे. फॉर्मूला में कौन सा टर्म किसको एक्सप्रेस करती है, जैसे कि हमने अर्थमेटिक प्रोग्रेशन में डिस्कस किया था. So the formula is Tn is equals to a r to the power n minus 1. चलिए पहले हम बात कर लेते हैं Tn. Term of nth position. A द फर्स्ट टर्म. यस, जैसे कि हमने एपी में देखा था, ए रिप्रेजेंट करता है फर्स्ट टर्म को, जीपी में भी ए फर्स्ट टर्म को रिप्रेजेंट कर रहा है. ओके जी, लेट्स टॉक अबाउट दिस. इट्स कॉल्ड कॉमन रेशियो, which is represented by small r, and we have n position of the term. This is the way the formula expressed.